Okay, back to it. New day, another math test. So, this is like practically tradition by now. But, oh, what? It's down here. I guess 2019 was a different year. Okay, so this is a Lagrange one. We gotta find the max value. So this is our F. This is our G. Okay. Standard practice, let's find the gradient of f first. So that would just be 8. That would be -6. Let's find the gradient of g. That would be 2 times x minus 1. X just becomes 1, so we'll ignore that. Then that would be 2y. Sweet. Okay, let's set these equal. So 8 is equal to lambda of 2x minus 1. -6 is equal to lambda of 2y. Okay, so here's how I'm gonna solve this one. This isn't exactly a fast problem, but we can optimize as much as possible. I'm gonna divide by 2 on this side. You get 4 equals lambda x minus 1. So x minus 1 is equal to 4 over lambda. I'm actually going to keep it like that for now. This one I can convert. I can just take over the 2. So -3 is equal to lambda of y. So y is just equal to -3 over lambda. Now, why did I keep it like this? Well, over here, it's just an x minus 1. So if we plug it back into the constraint, you just get 4 over lambda squared plus -3 over lambda squared equal 1. Let's check this out. 16 over lambda plus 9 over lambda equals 1. That's 25 over lambda. These should be squared. My bad. Equals 1. So 25 equals lambda squared, which means lambda is just equal to plus or minus 5. Okay. So now that we have that, let's plug these back into these equations right here. So when lambda is equal to -5, I'm going to say that y is just equal to -3 over -5, which is just 3 over 5. X minus 1 is equal to 4 over -5. X is equal to -4 over 5 plus 1, which is just 1 over 5. So you get your critical point at 1/5, 3/5. So that's our first critical point right there. And then, oh, my bad. Okay. For the next one, you get lambda is equal to 5. So that just means y is equal to -3 over 5, which is just -3 over 5. And then x minus 1, my lord, is equal to 4 over 5. So x is equal to 4 over 5 plus 1, which is just 9/5. So at that point, your critical point is 9/5, -3 over 5. So those are our 2 critical points. Let's plug them back into our original equation. So when f is 1/5, 3/5, we get the equation 8 over 5. Actually, let me write this all out for you. 8 times 1/5 minus 6, 3 over 5. You get 8/5 minus 18/5, which is -10 over 5, which is -2. Let's try the other point, which is 9/5, -3/5. So you get 8 times 9 over 5 minus 6 times -3 over 5. So you get 72 over 5. At this point, it's plus 18 over 5. Oh, what the heck? which is equal to 90 over 5, which I believe equals to 18. And that's our answer. And we're bringing back the smiley faces. Okay, that's a long problem. Okay, let's evaluate this over these two bounds. So I'm gonna evaluate over x first, which is 1 to 2, y is 0 to 4. I'm actually gonna pull the y out for now, so you just get x squared over 2 plus x cubed. You can do some u substitution, 2 plus x cubed, which means our du is just 3x squared. In this case, that just converts to 1/3. 1/3. Our bounds, I will find that eventually 1 over u. So if you plug in a 2, 2 plus 2/3 is equal to 2 plus 8, which is 10. Sorry for the bad handwriting. And then 2 plus 1 cubed is equal to just 3. So in this case, you get 1/3, and this just becomes natural log of u. That's the integration. So you get 1/3 natural log of 10 minus natural log of 3. Sweet. Okay, so now I'm actually gonna pull, oh my lord, I'm gonna pull all of that out to the side in order to do my y, which is pretty simple. You integrate that, just y squared over 2 from 0 to 4, which gets you 16 over 2, which gets you 8. And then you multiply, let's use a different color here, let's use blue. Multiply that onto that, which means you get 8 over 3 natural log of 10 minus natural log of 3. In this case, that is answer choice C. This allows us to do C or E. We're going to choose C. And yeah. Okay, number 3. Evaluate this integral I by switching the order of integration. So let's do this by drawing it out first, shall we? Okay, so this is dx dy, so we know that y squared is less than x, which is less than 2 pi. So y squared looks something like that. So x equals y squared, and then it just goes to some x equals 2 pi in this case. And then y is from 0 to the square root of 2 pi. So we got 0 here, and the square root of 2 pi is somewhere in this area probably. So it's all this. So you change the order of integration. Now go from this, and now it's like this. So I would do this. So y is equal to, x is equal to y squared, which is the same in that case as y is equal to square root of x. So now y goes from 0 to x to the square root of x. So 0 to the square root of x. In this case, x just goes from 0 to 2 pi. And that's that. Now we just got to evaluate it. 0 to 2 pi, 0 to the square root of x, y cosine of x squared, dy dx. Now, since we switched the order of integration. Okay. So in this case, y is the only thing that we need to care about. It just becomes y squared over 2. 0 square root of x, which just gets you x over 2 minus 0, which is just x over 2. And now we gotta do this big one, x over 2 times cosine of x squared. This is actually relatively simple. We do the u substitution of x squared. So du is 2x. And in this case, we have this right here. So x squared, if we want to turn it into 2x, we just multiply it by 4. So we have to put a 1/4 there. Oh, what the heck? Okay. So then our bounds, in this case, 2 pi squared equals 4 pi squared. And then 0 just stays as 0. Cool. So now we have cosine of u dx, which will, you know what I'm going to do? I'm going to take this and I'm going to transfer it over here. This now just becomes sine of u from 0 to 4 pi squared, which simply becomes sine of 4 pi squared over 4 minus sine of 0, which is just 0. So our answer is sine of 4 pi squared over 4, which is d. In this case, that is correct. Okay, that was also a long one. Man, these are all long. Okay, which of the following iterated integrals is equal to this triple integral right here for all continuous functions defined on D? So we know that x is equal to 0, z is equal to 0, y is equal to x, and x plus y plus z is equal to 2. Okay, so if we look here at our answer choices, it goes dz, dy, dx. So that's the order we're going to go in. So how I would do this is I would put everything off to the side except for the one you're looking at. So z in this case would be equal to 2 minus x minus y. And since we also know that z is equal to 0, we can set that equal to 0. And since the second term we're trying to find is y, you can just say 2 minus x is equal to y. So let's see this. All these stay the same. We haven't eliminated any answer choices yet. And then if we look at our y, 2 minus x, this is 1 minus x, this is 1 minus x, this is also 1 minus x. Can't be any of these ones. Oh, whoops, I just took that one out. And in this case, we also know that y is equal to x. So do the same thing, set it equal to x. So now you know that 2x is equal to 2. See that x is simply just equal to 1. So in this case, x is equal to 1, but in this one, x is equal to 2. So now the answer is D. Cool. Okay. Evaluate this integral using cylindrical coordinates. So that's going to be our r, dr, d, dz, d theta. Okay. Sorry, I had to stretch out my arm there for a second. Okay. So, these are our z's. So z is equal to 2, and we know that x squared plus y squared is equal to r squared. So we're going to keep it like that. In this case, z is equal to the square root of r squared, which is just r. So we're going to keep it like that, actually. We're going to make z our first bound. 2 minus r squared. Nice. Okay. Now we have our dy here, so we know that y is equal to the square root of 4 minus x squared, which means that y squared is equal to 4 minus x squared, which means that x squared plus y squared is equal to 4. R squared is equal to 4. You square root both sides, so r is just equal to 2. So our second bound would be from 0 to 2. And then in this case, we know that x is always positive, which means it goes from 0 to pi over 2. 0 pi over 2. Sweet. Okay, and now we just evaluate that on cylindrical coordinates, which means we have to put in the r, dz, dr, d theta. Okay, so this first integral is pretty simple, since it's just dz, which means that it's just z from r to r squared, square root. So square root of 2r squared minus r, That's all times r. So r square root of 2r squared minus r squared. So now we have from 0 to 2 of r 2r squared minus r squared dr. I would separate these. I'm going to make all my work a little bit smaller so that I have some space to do this. Should have thought of that. Okay, so let's do this one first, shall we? So we can do u substitution. U is equal to 2r squared. So the du is equal to 4r. So we just put a 1/4. 1/4. Our bounds now become 2 times 2 squared, which is 4, so 8. Then 0, which is just 0. And now you have the square root of u. So that becomes 2/3 u 3/2. Don't forget the 1/4. You get, this becomes 2/12, so we can just say 1/6. U 3/2 from 0 to 8 to 0. So you just get 1/6 8 3/2 minus 0, which you can just say is just, in this case, 1/6 times, which is just 8 square root of 8/6. I will eventually rewrite that, but this just becomes 0 to 2 of r squared equals to r cubed over 3 from 0 to 2, which is just 3/8. Okay, so let me take these two right here. So now you got 8 square root of 8/6 minus 8/3 bound between pi/2 to 0. Now in this case, I will simply rewrite the square root of 8 to 2 square root of 2. So now I have 16 root 2/6 minus 8/3. And then once you do that, you just add in a theta. You just get 16 pi/12 minus 8 pi/6. So now I just got to do a little simplification, which just becomes, in this case, I can divide both of these by 2. So I get 4, not 4, my bad. I get 8 pi/2, 6, minus 8 pi/6 root 2. So I'll just simply take out the 8/6 pi, leaving the square root of 2/1. We can further simplify this by dividing by 2 to get 4 pi/3 square root of 2 minus 1. These are all very long questions, and my wrists very much hurt. Okay, by converting the integral, whoa, let me just write that out, to spherical coordinates, so remember that's rho, phi, theta, we obtain the integral. Very cool. So b times c/a equals, so it would be this times this divided by a. Okay, sweet. So let's see what's first on the chopping block. Okay, so we know that rho is equal to the square root of 4 minus x squared minus y squared. Whew, wow. Sorry, no, we don't know that. My bad. We know that z is equal to 4 minus x squared minus y squared. So we can say that z squared is equal to 4 minus x squared minus y squared. So x squared plus y squared plus z squared equals 4. We know that equals to rho squared equals 4, which means that rho is equal to 2. So in this case, let's make a little thing here. C is equal to 2, B something, A something. Cool. Okay, so we know that our rho is 2 now. And in the same case, we also know that Z is equal to square root of 3 x squared plus y squared. In this case, I will convert this to their forms, which is rho cosine phi equal to the square root of 3. This will be very long to write. Phi squared sine squared, rho squared sine squared of phi cosine theta plus rho squared sine squared of phi sine theta. Whoa. Oh, I had more space there. That sucks. Square both sides, so phi rho squared, oh my god, is equal to 3 rho squared sine squared of phi. And what you can do is, these should be squared, oh my lord. Sorry folks. Plus sine squared of theta. So we know that 3 rho squared sine squared of phi is equal to rho squared cosine squared of phi. In this case, you just take out this. You get sine squared over phi divided by cosine squared over phi, which just equals you out to 1/3. So now that tangent squared of phi is equal to 1/3. In this case, we know that phi is equal to pi over 6, because if you look at pi over 6, 6 is equal to square root of 3 over 2, 2 over 3. So 1 half over square root of 3 over 2 is just equal to 1 over square root of 3, which is square root of 3 over 3. If we square that, then you just get 3 over 9, which gets us 1/3. So we know that our phi is pi over 6. So let's write that here. Now, in order to find our theta, you could just look at this. We know that y is equal to the square root of 1 minus x squared, which means that y squared plus x squared is equal to 1. So we know this is a circle. So you could say that that's just phi is equal from 0 to 2 pi. But if you want to further prove it, you can say that x is equal to 1, which means that rho sine of phi cosine theta equal to 1. So we already know that rho is equal to 2 sine of pi over 6 cosine theta equals 1. You know that this is equal to 1/2, so that means 1 times cosine of theta equal to 1. So we know that theta is equal to 0 or 2 pi. So in this case, our theta is just equal to 2 pi. So, okay, now we just got to do b, which is pi over 6 times c, which is 2, all divided by a, which is 2 pi. So you get 2 pi over 6 over 2 pi, which means you get 2 pi over 6 times 1 over 2 pi. These cancel, and the answer you get is 1 over 6. There we go. Okay, find the volume of the solid enclosed by the surface. In this case, how you would actually, I think I want to start this question is by doing something kind of weird. You multiply everything by rho. So you get rho squared equals to 12 rho cosine of phi. In this case, we know that rho squared is equal to x squared plus y squared plus z squared. And we know that rho cosine phi is just equal to z. So this is just equal to 12z. So x squared plus y squared plus z squared minus 12z is equal to 0. Now we just complete the square. Complete the square. Complete square. Cool. Okay. So we know that this becomes negative 12 over 2 is equal to negative 6. squared equal to 36. So you got x squared plus y squared plus, and in this case we do z minus 6 squared is equal to 36. So we know that this is our radius squared, so radius is equal to 6. And the coordinate for the origin center, is at 0, 0, 6. So if you draw this out like this, you'll have it at around right here, which is 0, 0, 6. You have this like spherical object. Since the radius is 6, it does touch that axis. But here's a little trick, right? So we know that the volume of a sphere is 4 over 3 pi r cubed. We already know our r right here. So we can just plug that in. 4 over 3 pi 6 cubed, which is equal to 216. 216 times 4 over 3 is all pi, is equal to 64 pi over 3, pretty sure. And if you do that, 864 over 3 to 6, 824 to 4 is equal to 8, which means you just get 288 over pi. That is our answer. Oh wait, have I not been checking? Oh gosh darn. 5 is B. 6 is E. And 7 is in fact A. Okay. Now we gotta calculate the mass of a tetrahedron with these coordinates. So we got 0, 0, 1, 0, 0, 0, 2, 0, and 0, 0, 4. So, kind of looks something like this, right? This weird shape. How I'm going to go about solving this is by finding the floor, like this. So, if we set this floor, this is x, this is y, you got 1, 0, you got 0, 2. So we know that in this case, y would be equal to 2 minus 2x, and x would just be equal to 1. So we got our first two bounds already done. 0 to 1, and 0 to 2 minus 2x. And then if we set up the bounds z, y, then we would know that it goes from 0, 4, this is z, this is y, and it would be 2, 0. So in this case, we would know that z is equal to 4 minus 2y. We can just plug in a y here. So 4 minus 2, 2 minus 2x equals to 4 minus 4 plus 8x. Not 8x, I appear to be tripping. 4x, so we know that z is just equal to 4x. So that's our third bound. It goes from 0 to 4x. And they just gave us 2z right here. So we go dz, dy, dx. So this would be z squared from 0 to 4x, which is equal to 16x squared. And then if we take it over here, sorry folks, I like jumping around the place. We just get 16x squared y from 0 to 2 minus 2x equal to 2 minus 2x times my 16x squared. You get 32x squared minus 32x cubed. So from 0 to 1, 32x squared minus 32x cubed. We can just take the 32 out. X squared minus x cubed dx. This is just equal to x cubed over 3 minus x to the 4th over 4 from 0 to 1, which is simply equal to 1/3 minus 1/4, which is 4/12 minus 3/12, which is just 1/12. And then you just simply multiply back the 32, get 32/12. If we divide both sides by 4, you get 8/3. And that is our answer. If we check back with 8, it is in fact B. Okay, a potential for the vector field F is equal to sine y x cosine y. Okay, so remember, for the potential thing, you got to find the integral of F, and then the integral of F at x, and then you take the derivative at y, and then you find. So that was a really bad explanation, but I'll show you as we go along. So you take the integral of this with respect to x, so you get x sine of y. Then that's our step 1. Our step 2, you take the integral, you take the derivative, the derivative with respect to y, so you get x cosine of y. Oh my lord, folks, sorry. There's a constant here. That becomes a prime of y. Then you simply set this equal to the next component in line, which in case is g. So we know that x cosine of y plus a prime of y is equal to x cosine of y. So in this case, they cancel out, and we simply get left with f a prime of y is equal to 0. So our potential function is just simply equal to x sine of y plus a constant. So if we look at answer choices, nope, that's a cosine. Nope, that's in the wrong form, and that's also a cosine. It's not exactly a constant, so our answer is E. Yay. Okay, let C be the curve r of t cosine t sine t t. T goes from 0 to pi/2. And f of x, y, z is equal to xy. So this is a line integral. And we're going to solve it by finding r prime of t first. So r prime of t is just negative sine of t, cosine of t, and 1. Then we got to find the magnitude, which in this case is sine squared of t plus cosine squared of t plus 1, which is just equal to 1 plus 1, which is the square root of 2. Okay, now we got to find f with plugging in r and t, which is just equal to cosine t sine t. Sweet. So now we got to do f times r prime of t. That's the integral dt. So this will be from, as they told us, 0 to pi/2. I'm going to actually take the square root of 2 out so I can just deal with these two things, these two trig functions. So in this case, I'm going to set u substitution. U is equal to, whoa, what just happened? Sine of t. Du is equal to cosine of t, so that's already there. So now we just get 0, sine of 0 is equal to 0, sine of pi/2 is equal to 1. Let's get u, 2 still there, which simply translates to u squared over 2 from 0 to 1, which is just 1/2 minus 0. Remember, this is still square root of 2/2. Now you look at your answer choices and you're like, well, there's not a square root of 2/2. There actually is. A is our answer, and let me explain why. You see, if we have the square root of 2/2, I'm going to do this thing where I'm going to time reverse, time reverse. And you can think of this as 1 over square root of 2. Because how do we fix 1 over square root of 2? We simply multiply top and bottom by square root of 2, which gets you square root of 2/2. Square root of 2/2 is the same as 1 over square root of 2. They're the same thing. They like each other. And thus our answer is A. And our answer is A. Sweet. Last question of this video. Let C be the half circle x squared plus y squared equals 4, and x is less than 0. Let's cover this first. So we know x squared plus y squared is equal to r squared equal to 4. So we know that r is equal to 2. Now, this is important because we need to parameterize this. So if it's a circle and you parameterize a circle, it'll always be r cosine t, r sine of t, which means the parameterization of this will just be 2 cosine t, 2 sine of t. Sweet. Now we also know it's a half circle and x is less than 0. Now usually I would just say it's from 0 to pi over 2, but it's a half circle. We can't go further than this. This is no man's land, so we got to go under. So in this case, our bounds will actually be from negative pi over 2 to pi over 2. So now that we have our bounds, we know that this is our f. So f of r of t is just equal to, in this case, this is our r of t here, it's just equal to 2 cosine t. So we need to still find this. R prime of t is simply equal to negative 2 sine of t, 2 cosine of t. So the magnitude of r prime of t is equal to 4 sine squared of t plus 4 cosine squared of t, which is just equal to 4 sine squared of t plus cosine squared of t, just equal to 4 square root equal to 2. Okay, so f times the magnitude of r prime of t from negative pi over 2, pi over 2. Holy moly, my handwriting keeps getting worse. dt. I'll just be equal to 4 cosine of t. Whew. So in this case, we translate that over to 4 sine of t from negative pi over 2 to pi over 2, which gets you 4 sine pi over 2 sine pi over 2, minus sine of negative pi over 2 is equal to 4 sine pi over 2 is equal to 1, minus sine negative pi over 2 is equal to negative 1. So you just get 4 times 2, which is 8. This cancer, this way. Yep, that is our final answer. And pat yourself on the back, you have finished another practice exam for this class. So happy. Okay, I hope you learned something. Thank you.